Welcome grade 11s to the cosine rule video. So this is a follow-on from the sine rule. So moving on quickly, the cosine rule proof is very similar to the sine rule proof. And so you again start with a random triangle ABC, or really any letters. It's just not a right angle triangle. So this is A, B, and C. And then across from B is little b, across from A is little a, and across from angle C is little c. So just like we did in the sine rule proof, we are going to drop a perpendicular down, and we are going to call the one portion X. This whole side was called C. So that little C there was the whole length. So now if we've called one of the portions X, we are going to call the other portion, so this little one, we're going to call it C minus X, just like we see in this graph, because it was the full side C, and then we took X and we broke it off. All right, so that's just the procedure that you have to follow. And then on the next slide, you'll see the proof of the cosine rule, very similar to what the sine rule was. Just the cosine rule is just a little bit longer, and it's not in fraction form. All right, so moving on from this point, we're going to use two different versions in order to work out this new rule that we are going to learn. So we are first going to look in this triangle ACD, this big one on the left-hand side. All right, so now using Pythag, we have three sides here. We've got X, H for our height, and B there being our hypotenuse, because it's across from the right angle. So B squared is going to be equal to your other two sides squared and added together. All right, so that is a representation of B squared. So wherever we see a B squared, we can put that in, for example. All right. Then we could also use the idea that we worked with the sine rule, where we look at, obviously for cosine now, cosine is adjacent over hypotenuse. So cos of angle A is adjacent over the hypotenuse. All right. And in this case, again, just follow what I'm doing here. We're going to get X by itself and move the B across. All right. So then, in the other side, the other triangle, so we have this triangle now. All right, triangle BCD. If we're going to do our Pythag again, it's going to be our hypotenuse, and then we're going to square each of the other two sides and add them together. And then what's happened here is that this portion is foiled out. All right, so you're foiling that yellow bracket, but then now here's the thing. We got to get rid of anything that has X's and H's in, because that was not part of the original triangle. Now I know you think little a, little b, little c wasn't, but they belong with their angles A, B, and C, which was in the original triangle. So wherever we see an X, we can replace it with B cos A. So I see an X in my foiling there, I can replace it with B cos A, because that's from the original labeling of the triangle. Then wherever I see this H squared plus X squared, I can replace it with a B squared, because that's what it's equal to. All right, so then we've gotten rid of all our X's and all our H's, and we are left with this. That is the first version of the cosine rule. So you say, and if we have a look at the original triangle, that was A, C, B over there, there's little a. So if I look at A squared and cos A, can you see that the side and its angle are opposite each other in the question and in the triangle? And then the other two sides, the C and the B, are involved. So you always take the side that you're working with, cos of the angle opposite on the opposite side of the equation, and then you take the other two sides, you square and add them, and you subtract 2 times the product of those with cos A, or with the cos of the angle you're looking at. Again, this is something you'll need to see in practice with actual numbers, so let's get on with some examples. Okay, so this is for any triangle ABC, and what you can also see is that this has been rearranged, so you don't have to learn this formula. You can just work with the original formula and rearrange it as you need if you need to solve for cos A. But if you're trying to solve for the angle, you can learn this formula. But I just think it's a waste of time. Rather just learn one and rearrange it algebraically. Okay, so these are the different versions. If you want to work out B squared, you'll have its angle opposite in the question, and you will work with the same formatting with the other two sides. If you're looking at C, then they will be opposite each other in the question, and then you'll use the other two sides in the rest of the question. Okay, let's go on to some numbers. Okay, so let's go into a number example. It just makes it a little bit easier to understand. So it says here, solve for the unknown sides and angles. So let's first start with why couldn't we use the sine rule here? So let's see what we've been given. We've been given an angle, and we have not been given its opposite side. Now, we have been given no other angles, so in this case, you wouldn't be able to use the sine rule because you need a full pair, angle and opposite side. So as you go along, you'll see you don't have enough information for maybe the sine rule or the cosine rule, so then you'll know which one to pick. So when we're working with the cosine rule, we need to see what we're being asked for. So the unknown sides and angles. So let's start by looking for this unknown side. We're going to call it QR. So what I'm looking for first, I'm going to call it QR, and in this cosine rule, we are working with a squared side. So QR squared equals. Now I'm using the cosine rule, so I know I've got to look at its opposite angle to that side at the end of the question. So cos 40 degrees. Then we take the other two sides and we put them in that same procedure. It's going to be 11 squared plus 6 squared minus 2 times 11 times 6 times cos 40. So once you've established the side that you're looking for and then the angle that you have opposite it, you are going to put them opposite in the question and then fill in the other two sides in any order, squared and added together, and then subtract 2 times the multiplication of those two sides times cos of that angle that you're looking at. All right, so in your calculator, you'll work out what QR squared is, and then you'll be able to square root and get QR by itself. Please show your steps for the QR squared and then the QR at the end. So in your calculator, you're just going to pop in this whole bit and get an answer. Don't round off. So you'll show it as your QR squared is 55,882 something, something, something. Don't round off. Keep the whole number in your calculator. Press the square root and use your A and S button, your answer button, and use the full answer from the second step and then square root it to get your final answer of 7,48. And it kind of matches where we've got our 11, 6. We can't have a big number like 55. That means we had to square root it. All right, so we've got our third side there, and now we can work out our missing angles. So that's 7,48. So now you can choose which angle you want to work with first, because now you have a complete side. Now, if you end up messing up the answer, it's fine. Remember, we will give you error marks. Sorry, let's just fix up that. All right, so I'm going to work out angle Q first. So angle Q is opposite to the side 6. So I'm going to go with sine of Q over 6 is equal to the sine of 40 over 7,48. So now you're probably thinking, but now we're using the sine rule. It's fine. You can mix the rules. You don't have to use the cosine rule all the time. You can work with the sine rule once you've got enough information. So then I'm going to multiply that 6 across. And then in my calculator, click Shift Sign, and then get my Q as an angle. So I get Q to be 31,04 degrees. Again, you could have used the cosine rule, but it's more complicated because you end up having to rearrange. And then from that, we can say angle R is equal to 180 minus 40 minus 31,04. And that gets us 108,96 degrees. Again, you can see R is quite a large angle. It is obtuse, so we don't have an issue when we're looking at the ambiguity here. If you are working with the sine rule, though, and you ended up getting angle R using the sine rule, if you had done angle R before angle Q and you got R as an acute angle, you're going to have to use the ambiguous case and work out the obtuse. So that's why it's just better to rather work with the smaller looking angles, then they don't give you any issues. And don't forget here your angles of triangle. I want to just go through if we were to use the cosine rule here. So angle Q is across from 6. So we'd have 6 squared equals and then cos of angle Q. Opposite in the question because they're opposite in the triangle. Then we'd use our other two known sides here that are surrounding the angle. 11 squared plus 7,48 squared minus, running out of space here, so let's just fix that up, minus 11 times 7,48, that's multiplied by 2 cos of the angle Q. So then now I would take all of this over, so it would be 6 squared minus 11 squared minus 7,48 squared is equal to negative 2 times 11 times 7,48 cos of angle Q. This whole piece is being multiplied, so we can divide it on the other side. And get rid of it over here. So to get our cos Q by itself. Then your calculator shift cos of this whole big fraction and then get your angle Q by itself. And that gets me to 31,07 degrees. So it's a little bit different in the rounding, but we'd accept both ways. It's just because of the different ratios and the rearranging. So, and remember, we've worked with a rounded answer here already from the previous question. So the rounding can change, but we would accept it either way, which means your rounding for your R would be slightly different. But the idea is that because of the rounding, we will accept this little bit of inaccuracy. All right, so then moving on to the next one, solve for the lengths of the unknown sides and angles. Again, if we look, here's our angle, we don't have the opposite side. So let's work out TK first. TK squared is our focus because that's our first side we're looking for. The other two we know. We're going to kick our angle to the opposite side of the question because it's opposite that side. Then we're going to use the other two sides, square them, add them together, subtract 2 times 9.5 times 4,7 times that cos 96. Pop that all into your calculator in one go, get an equivalent, and then square root it to get TK by itself. And we get 11,03 units. And then again, you can choose what rule to work with, but the sine rule is the easier rule to go with. It just comes with ambiguity as a problem when you're working with angles. So it's up to you. I'm going to do the cosine rule just to get you more into the habit of working with it. All right, so we've got that 11,03 there. We've got our grouping. So if you wanted to use the sine rule, you absolutely are welcome to do so. But let's focus on the cosine rule. So let's start with angle T because it's definitely an acute angle. There's no mistaking about it. There's no issues there. So I would say you'd start that even if you're doing the sine rule. Okay, so I'm looking what is opposite. So 4,7 all squared is equal to, and then we're going to have our cos t on the other side. You can work with the already rearranged version of the formula if you want in the previous slides, but I like just to have one formula, you learn one formula, and then you adapt it. So I've got my angle that I'm focusing on and the side opposite on the opposite ends of the question. So now what else is left? We have our 9.5 and we have our 11,03. All right, and it's always the angle is the included angle between those two sides. So then minus 2 times our 9,5 times 11,03 cos of t. We're going to take the square ones across first, so 4,7 squared minus our 9,5 all squared minus our 11,03 all squared, and you divide by the next piece in front, negative 2 times 9,5, 11,03, and that's equal to cos of the angle that you're looking for. All right. And so you'll say shift cos of that entire fraction, and you'll get your angle t by itself. And your answer here is going to be 25,07 degrees. If you use the sine rule, you might have got a slightly different answer. That's perfect. All right, as long as it's within that range. And then to get our angle K, it's going to be 180 minus 96 minus 25,07. And that is angles of a triangle. And you get 58,93 degrees. All of our angles there are acute. Well, our T and our K, our M is bigger than 90 degrees. Okay, so here we have a situation where they've given us all three sides and they want to know the unknown angles. So I would say always start with an acute angle. Let's start with A. So it's going to be the side that is opposite the angle we're looking for, and then cos of the angle on the opposite side because it's opposite to 10. So we're going to have our other two sides. In that format. Same thing as before, you can then just subtract and divide always by the same algebraic maneuver. All right, and then in your calculator, shift cos of that fraction and you'll get angle A. And that gets you to 56,83. All right, so now if you're going to go along with the sine rule, there's a bit of an issue here. You will probably find potentially that angle B, you can see it's quite large in the picture, so it could potentially be obtuse, and you might not get an obtuse angle from the sine rule and have to read into the ambiguous case. So I would still go for working out angle C first, even if you're using the sine rule, because angle C is very definitely acute. It's very small. So go angle A, angle C, those are the acute angles. Leave angle B for angles of a triangle, because then you will get that obtuse angle and there will be no ambiguity there. All right, so let's go for our angle C. It is opposite to 9. So again, you can use your cosine rule or your sine rule. It's completely up to you. Let's use the sine rule here. So we now have a full angle A. Let's just put this all in. So we have angle A is 56,83. So there's our complete pair. And now we can work out angle C. So sine of angle C over its opposite side. And then we put the angle on the top, sine of 56,83 all over 10. Again, if you choose to use the 56,83, we'll give you error marks. Right, get that 9 across. Shift sign of that fraction and get your answer. All right, so I've worked out angle C using my sine rule, and I've also just, while I paused, I worked out using the cosine rule, and it will give me the exact same answer there. So this is very definitely the angle C. It's exactly the same 2 decimal places. So in this case, angle B is deceiving in the picture because it actually ends up not being obtuse. So that's why I say rather stick with the acute angles. Sometimes the pictures are misleading. All right, and now for the last one of this page, we are working out, again, the unknown angles. Let's start with angle N. It's quite small looking, so that's a safe one. Then we'll go to L, and then we'll leave K because it's the obtuse looking one for now. All right, so N is across from from side 6. So that is what we're going to be focusing on, 6 squared, and then opposite, it's going to be cos of N. And we're going to use the other two sides squared and add it together and subtract 2 times those two sides multiplied to that cos N. All right, so then to get our cos N by itself, you subtract the squareds and you divide by the -2 and its multiplication to get cos N by itself. So in your calculator, shift cos of that fraction and you're going to get N by itself. And you get it to be 17,4 degrees. Again, I'm going to go with L next. You can choose to use the sine rule or the cosine rule. Let's use the cosine rule just to be different from the previous question. So L is across from 15. So I'm going to start with 15 squared and then have my cos L at the end. So my other two sides, not the 15, is going to be my 6 squared plus my 18,3 all squared minus 2 times 6 times 18,3. Take the squareds across, subtract them from the 15 squared, divide by the -2 and its brackets, and you get cos L. And so shift cos in your calculator of that fraction and you get L to be, L is 48,37 degrees. So now you can work out angle K by using your angles of a triangle. So angle K is going to be 180 minus your 17,40 minus your 48,37 angles of a triangle, and then K is equal to 114,23 degrees. So again, if you'd used the sine rule, you might have come up with a problem with an acute angle there and have to use the idea of the ambiguous case. You might have gotten an answer of 65,77, and that would have not fitted the picture, which K is shown to be obtuse. So now it doesn't always mean K will be obtuse if the picture shows it, but if you're using the sine rule, you got to go with the gut instinct that if it looks obtuse, it must be, and then use the ambiguous case. But if you've used the cosine rule, there is no ambiguous side of it, so this will be accurate then. So it's up to you which rule to use. Just watch out for that ambiguity. All right, so this is just an additional example for you to show you where and when you would want to use the cosine rule. So here they've given you two sides in a triangle and the angle between them. So side, and the angle between them, we call that the included angle. And the question is asking to find the side A, the little a. So A is opposite 48 in the diagram, so it needs to be opposite to the cos 48 in the question, and then you fill in the other two sides in that format. Remember, you don't need to show us the letter version of the formula. It's not like physical sciences. All right, and then don't forget 2 decimal places. Then you have this scenario where you have been given all 3 sides and no angle. Right, so here they're asking for angle A. You've been given 3 sides, so you would use 8 squared across from cos A at the end. So you can try this on your own and work out your angle A. I've just put in B and C as well if you want to practice some more. Those are just the answers. Right, so these are the 2 scenarios that you would use the cosine rule in. 2 sides in the included angle, or if you're given all 3 sides and no angles, then the cosine rule is the necessary rule to use.